Okay, so for the next class or two, we're going to talk about your framing square. I used to have one in here, but I took it home here a couple summers ago because I bent my other one, so I needed it for the summer, and I haven't brought it back in yet. The framing square has a lot of information on it. Pretend that kind of looks like your framing square. Yeah, I know, I can't draw. Your framing square has two pieces on it. So this is called the body, or sometimes called the blade of the framing square. And this up here is called the tongue. And most of our useful information is down here on, I can't work this thing today. Yeah, most useful information is down here on the body. Now, if you start at the corner of the framing square, it's labeled on outside and it starts at 0 here, 1 inch, 2 inch, 3 inches, and so on. And it's numbered up. And it is those outside numbers that we are going to be using here. If you look at the framing square, if you look in your little book, page 111 in your little book, there's actually a picture of the blade. Actually, there's one on 110 as well, of the blade of your framing square. And there are actually 6 lines on that blade that describe different things for us. So starting here at the corner, this top line is labeled length common rafter per foot. Per foot of run is usually how it's labeled. What that is saying is, if you have the slope of your common rafter, this will give you the length of the rafter if you know what the run is. And so, of course, up here, this is going to have your slopes. It might start, I think it starts at 18 is the first one that's labeled, 17, 16. And those are just the inch divisions on your framing square. So it starts out at 1 and goes up through well, it usually goes up to 24 on the 24 by 18 is your framing square, right? If I remember right. So anyway, these are your slopes. So of course, we're not really concerned until you get down to like 8, 7, 6, 5, 4. Your 4, 6, and 8 are your most common slopes on roofs. I should have moved this down and did it a little bit better, but anyway. So if you look at that, let's say for 18, it says 21.63. Usually 21 space 63 like that. That means 0.63. What that is saying is for an 1812 roof, for every foot of run, so every 12 inches of run, so this is 1 foot of run goes this way, the length of this slope is 21.63 inches. Some of your framing squares are labeled in 1/16 of an inch, so it might say 21 and 5/8 or 11/16 or 9/16, whichever it's closest to. This would actually be closest to 5/8. So some of them are labeled in fractional inches down to a 1/16, but most of them are labeled in decimal inches. The next line is going to be length of hip or valley rafter per foot of run. What this is if you're doing a hip rafter, a hip roof, which is like this lovely thing here. I'll put it on this thing here. I mean, this is your common rafter right here. It's your common. This is the run we're talking about. So we keep that same run, but now we're looking at a hip roof. So we're looking at this rafter going up the corner. Now again, without the overhang figured in. You would have to add the overhang to the run to get the total length of the overhang on the common rafter. use that same run then to get the overhang attached to the hip rafter. That is how long it goes up the corner there. So like for an 1812 roof, that number is 24.74 inches. So again, you can see that that's longer than the other ones. Considerably longer because it's got to go corner to corner instead of just up and down. You can also use that conversion to convert your slope, by the way. You can see that that hip corner, that corner rafter, is going to have a less slope than these. These are going to be steeper going up because this has same height but a longer distance to get up to that height. Next thing that's going to be on there is going to be the difference in length. For jacks, what is the first one? 18 or 24 inch? 16 inch spacing. So 16 on center. The next one is difference in length of jacks, 24 inch on center. So it depends on whether they're spaced 16 inches apart or 24 inches apart. What that is talking about is, yes, in a valley or hip roof like this is a hip roof here. This is the main hip jack right here. That's going to be identical if you have the same slopes. This only works if you have the same slope on the hip side of the roof and the main side of the roof. The framing square does not work if they're different slopes. But anyway, same slopes. This main jack here on the hip is going to be the same length as your common rafter. So you can find that length just off the common rafter calculation. This next jack is going to be shorter than that one, obviously. And the difference in that one, from the longest one to that one, is the same as the difference from that one to the next one. In fact, the difference in length is the same as you go down each step of that. We'll show how to calculate that actually next semester when we go over calculating. But for now, we'll use the framing square. So we're going to look at numbers that are a little more relevant. We're not going to keep writing down the 1812 slope ones. And the next one is something called side cut. The side cut goes off that hip jack. Although they're that hip corner, sorry, you got all those jacks coming into that corner like that. Well, you think it's a 45-degree cut. It's not, because they're standing up. If they're laying down flat, it would be a perfect 45-degree cut. But because they're standing up, it's slightly off from a 45-degree cut. So the angle is used on the framing square. So what you'll do, it'll give you a side cut of where are you? For the jack is going to be like 6 11/16 they're giving you. So what that means, 6 11/16, you're going to take your square, you're going to line up the board here at 12 inches on one side and 6 11/16 on the other side. And then when you line it up that way, this angle here is the angle you have to cut it at to make it match up. Does that make sense? Actually, I think it's this angle here is the angle you got to cut it at to make it match up. If I remember right, that's the one. So those are your side cuts for making your jacks all fit in. So you can see most of this is for your hips and valleys. It's those first two lines that are for common rafters. So let's take a look. If we have so we have length common, length hip, difference in jack, 16 OC, difference in jack, 24 OC. And let's start at like, 8 inches or so. So at 8 inches, length of your common is 14.42 per foot of run. And let's do for 24 on center, 28 and 7/8. It's listing here. So let's say I want to build a hip roof. And this roof, we'll drive over here. It's going to have a span of 32 feet. So I'm going to assume no overhangs right now to keep it simple. How long does this common rafter have to be? Well, what is the run of that common rafter? Half the span, right? Half the 32 feet. So that common rafter has 16 feet of run. So the length of the common is going to be the feet of run, 16 times 14.42. Gives us 230.72. Now that is inches. We want that converted to feet and inches, and probably to the nearest 16th of an inch. So how do we do that? Well, I'm going to do it right on my calculator. 230.72. To go from inches to feet, I divide by 12. So you're at 19.266 or 22666. So that is saying that is 19 feet. Okay, so it's divided by 12 and it converted to that 19.2266666. Now what I'm going to do is I'm going to subtract 19. Notice I have not hit clear, and at no point in this whole process should you ever hit clear of your calculator right now. I subtracted 19 and I got the 0.2266666. That's what's left over after I take out the 19 feet. So I'm going to multiply by 12 to turn that back into inches. So that's 2.72 inches. So that is now 2 inches. So I'm going to subtract 2, get rid of the 2. I'm now at 0.72. I want to turn that into, what fraction did I say? 16th. So I'm going to multiply that by 16. 11.5, which is going to be 12, right? Closer to 12 than 11. 12 sixteenths is going to reduce to 3/4. So that's 12 foot 2 3/4 inches. So the length, not 12 foot, 19 foot 2 3/4 inches is length. That means this first jack is also 19 foot 2 3/4 inches. How about this next jack here? Well, we know the difference is 28 and 7/8. 28 and 7/8, I'm going to write it like this. 2 foot 4 7/8. Okay? Why did I do that? Well, because now I'm going to come down here from my 19 foot 2 3/4. I'm going to subtract 2 foot 4 7/8 inches. So I borrow from the 2, make this a 1. How many fourths will this be? 7/4. Good. You always add the denominator to the numerator. So 7/4 becomes 14/8. I should have made that 6/8 first before I borrowed, but it works. So 7/4 becomes 14/8. 14 minus 7 is 7/8. 1 minus 4, I got to borrow. We'll make this 18 feet. So this is going to become 13 inches. Right? Because I borrowed 12 inches when I borrowed a foot. 13 minus 4 is 9. So this is 9 7/8 inches. 18 minus 2 is 16 feet. So this was the length of the common. The 19 foot 2 3/4 inches. After that longest jack, which is just a common rafter, the next jack, the first jack, is going to be 16 feet. I don't know if I put squared there. 16 feet 9 7/8 inches. Then, of course, to get the next one, I would subtract again. How much would I subtract? Same amount. 2 foot 4 7/8. Because that is my jack rafter difference. That's my difference. The difference from one jack to the next on an 8/12 roof will always be that amount. So I'll subtract. The 7/8 cancel out. 9 minus 4 is 5. 16 minus 2 is 14 feet. So the second jack (14 feet 5 inches). Does that make sense? Questions? So, using what they're showing you on page 112, I want you to find length of common. If we have .412 slope, and I'm just going to give you the run for this one. 12 feet of run. Try that in your notes quick. Put it to feet, inches, and 16th. I guess we're going to have to change this to a 512 slope. Sorry. 412 does not appear in the picture of your packet. So when you looked up the 512, what did you find? But when you look up under the 5 here on the picture, it's just 13. There's no decimal, right? So you've got 13 inches per foot of run. So you're just going to take 12 feet times 13, which is going to give you 156 inches. You are correct. So if I convert that to feet, inches, and 16th, what do I get? I get 13 feet exactly. Okay. So you look it up on here, you get the 13, right? So that's 13 inches per foot of run. So you take 12 feet times 13, you get 156 inches. Well, then I take 156 inches on my calculator. If I divide by 12, turn that back into feet, I get exactly 13. Yeah, she's gone.
Oh, she is?
Yep. Let's take a look at another example of this. Same type of thing. Find the length of the common if you have a slope of 712 and a span of 36 feet. Now remember, span is all the way across. What do we have to do to that then to get the run? Yeah, divided by 2. So the run is going to be 18 feet. So go ahead and find the length of the common. Again, feet, inches, and 16ths. So if you look on the square, what do you get for 7? 13.89. What are we going to do that? 18. Another run. So 13.89 times 18 gives us 250.02, right? Divided by 12 is going to give us 20. So that's 20 feet. So I'm going to subtract the 20 and then do what? Multiply back by the 12 to put it back in inches. So it's 10.02 inches. So that's 10 inches. I'm going to subtract 10. I got 0.02, right? What am I going to do with that? Well, I want this to be the nearest 16th, so times 16. I got 0.32, which is less than half, so that's not 1/16. It's just 10 inches. That's between 0/16 and 1/16, so it's closer to 0/16. So So 20 foot 10 inches is what that common rafter is going to be. Did you get anybody come close to that?
Yeah, 20 foot quarter.
A quarter?
I think I screwed up taking it back into inches. I just did after I minus the 20. I just did finish the curve.
Okay. Well, let's try another one here. Let's do a span of 40 feet. A slope of 812. Try that one quick and we'll go over it in a minute. So what number did you pull off the square? 14.42. What are you going to do with that? By 20. Very good. It's 288.4, right? So take my 288.4. I'm going to divide it by 12 to make it feet. So at 24 feet. So I subtract the 24. Then I multiply by 12 to turn it back into inches. That's 0.4. How many whole inches is that? 0. 0 whole inches. 0 inches. So now I got to turn, there's no 0. I can subtract 0 if I wanted to, but there's really, that's not going to do anything. So I'm going to turn it to 16. So times 16. 6.4. So that's between 6 and 7, closer to 6. So 6/16 of an inch. So that's 24 feet and 3/8 inches. I'm used to leaving a gap here for the whole inches, even though there are none, just to kind of accentuate that that is a fraction of an inch. There are 0 whole inches, and it's 3/8. Also because I'm used to doing operations with them, so I leave that gap so that when I line up the next one, it's lined up underneath the gap. I can put in 0 whole inches. How many of you got that one? 24 foot and 3/8 inches.
I did get something like that. My answer was 0.3 inches.
Okay, well, let's look at a 12/12 slope and 21 feet of run. So we look up 21, what number do we get? Or sorry, 12, 12/12, what do we get? 16.97. We multiply that by, why did I multiply by 21? It said run. The difference was up here it said span, right? So if it's span, you got to cut it in half. If it's the run, that's the number you want to use. I'll give you a second to redo that. So 16.97 times 21. 356.37, right? What are we going to do with that? Divide by 12 gives us 29 feet. Subtract the 29. Very good. Then what? Times 12, turn it back into inches. 8.37 inches, so we keep the 8. Then what? Subtract out the 8 whole inches. Then turn it into 16ths. So you get 5.9. So that'd be 6/16 or 3/8. 29 feet, 8 3/8 inches. Next, I want to talk about the difference between slope and pitch. You hear all the time someone say, oh, that's a 4/12 pitch or 6/12 pitch, right? Well, guess what? That's not correct. There is no such thing as a 4/12 pitch. 4/12 is a slope. So let's talk about the difference between a slope and a pitch. A slope is rise over run. Slope is always given out of 12. So that's what you hear, a 412 or a 612 or a 712. They are talking about a slope. So let's say this is a 24-foot span. And this has a height of 6 feet. What would the run be here? It'd be half the span, right? Which would be 12 feet. There's 6 feet of rise and 12 feet of run. It's a 612 slope. Now I made the run be 12 there so it was easy so we didn't have to adjust the fractions. We'll look at that in a little bit, how we do that if we had to. Pitch is rise over span. So what's the rise of this rafter? 6 foot, what's it span? 24. You're thinking run would be 12. Spans the whole thing. And unlike rise where we put it over 12, the pitch we would reduce. This would be a 1/4 pitch. The difference comes from the application. Pitch was back when we used old ridge beams. You needed to set the ridge beam up here, and you're going to cut rafters to go on top of that ridge beam. The height you set that ridge beam above the wall, all you had to do to find that height was take your span times your pitch. 24 times 1/4 is 6. So it'd be 6 feet above your wall that you'd set the top of that ridge beam. Does that make sense? That'd give you a 1/4 pitch or a 612 slope. Slope came about when they started building pre-made trusses. So you now got these pre-built trusses that handle all the load for you. So you don't have to have any ridge beams. Each truss is freestanding all on its own. So the slope then helps you describe what angles you got to cut everything at down here at the bottom or in the top. Even this angle here is described by the slope. 612 slope is more descriptive for that. So our question becomes, how do I convert from a slope to a pitch? Because what's given on the framing square, is that a slope or a pitch? Slope. 612, 412, 812, whatever. It is a slope that is given. So we need to be able to convert. If I have a slope of 412, to convert it to a pitch, it's really simple. Because the slope is rise over what? Run. Pitch is rise over span. Very good. How is the span and the run related?
The rise is half the span.
No, the rise is not. The run is half the span, right? So you double the run. If the 12 represents the run, what am I going to do to turn that into a span? Well, you're 24. So to turn a 412 slope into a pitch, I make it 4 over what's double of 12? 24. Then I can reduce that. What does that fraction reduce to? Perfect. It's a 1/6 slope. If I have an 812 slope, sorry, that's a 1/6 pitch, I should say, not slope. I have an 8/12 slope and I want to convert it to a pitch. What's it going to be? 8/24. And then reduce. Both of those can be divided by 8. This is the 1/3 pitch. In your notes, convert a 3/12 slope into a pitch for me, Craig. What'd you get? So it's a 3/24, which is, yes, a 1/8 pitch. Very good. I think you got that part down. What if I want to go the other way? What if I've got a 1/4 pitch? I want to convert it back into a slope. Not as hard as it looks. What's 1/4 times 24? Make it 24/1. 6. 6/12 slope. So if I have a 1/12 pitch, what am I going to do with that? 1/12 times 24 gives me what? 2. So it's a 2/12 slope. So in your notes, give me a 1/2 pitch. Turn it into a slope. What'd you get? Perfect, yes. 1/2 times 24 is 12. So it's a 12/12 slope. That part doesn't look so bad. So let's take a little bit of a review. So you got a 10/12 slope on an 18-foot run. Find the length of the common. What number did you pull off the square? That's it. 15.62. What do you do with that? So 18. Do you want a second to retry it? I will finish this one off, then I'll give you another one to work on. So 15.62 times 18. 281, so I'm going to divide by 12. 23. Subtract 23. Times 12, turn it back into inches. Oops, 12 might work better than 2. 5.16. Subtract 5 times 16 gives me 2.56. That's 3/16. So is that what you got, Jake?
Yep.
Perfect. Give you one more shot here. Just a little hint. A 1/3 pitch 48-foot span. Find the length of the common. So what's the first thing we got to do here? Okay, so you take 1/3 times 24 gives you 8, so it's an 8/12 slope, right? So it's an 8/12 slope we look up. Okay, and we're going to take 14.42 times 24. There you go. I need to be a little gun shy on that one. 346.08, so I'm going to divide by 12. 28 feet. Subtract 12. So why did I subtract 12? Why did I subtract 28? So we'll subtract 16. So 0.84, right? So I should have subtracted 28 to get to 0.84. Now times 12. 10.08. So that's 10. So what am I going to do with my 10.08? No, I'm going to subtract the 10 first. So 0.08 now times 16. So 1.28 is just 1/16. How many of you got that? 28 feet, 10 and 1/16 of an inch. Good deal. Well, I think what I'm going to have you do is in your little book. I want you to do Unit 23. Do all of it, not just the I, because there's not that many problems in there.